Welcome to the third unit of our error handling course. We've already explored how Make handles errors by default and discussed the use of simple error handling directives to customize this behavior. Now we're diving deeper into the concept of incomplete executions. You'll learn how to automatically retry them using the break directive. To make this learning process practical and engaging, we'll continue using the httpstat.us API. This helps in simulating errors to see firsthand how the break directive operates. So get ready as we delve into these essential techniques to refine your error management skills. Let's quickly revisit the concept of incomplete execution. Previously, you learned how converting errors into warnings allows your processes to continue even when an issue arises. While this prevents your workflow from halting, each warning results in an incomplete execution that needs your attention. Imagine you're sending an email, but there's a typo in the recipient's address. This error doesn't stop the process but flags it as incomplete. You must then manually correct the typo. This type of error is common, especially when users input their information. Understanding incomplete executions will help you manage these scenarios efficiently, ensuring your workflows remain smooth and effective. When you're dealing with incomplete executions, it's important to understand your options for resolving them effectively. Imagine you have a scenario running and something goes wrong halfway. You don't want to start from scratch. This is where you can edit from the point of failure onward. Think of an incomplete execution as a temporary module. It's like making changes to a draft instead of altering the original document. This flexibility is crucial, especially when your error involves unique issues like typos and email addresses. However, not every error requires customization. Sometimes the most efficient solution is simply to retry the same action. This is particularly helpful in dealing with transient errors, such as when your system faces too many requests in a short period, triggering a rate limit error, or when a server is down temporarily, leading to a connection error. In these situations, you can use a break directive to manage retry smoothly, allowing your process to handle the bumps without much manual intervention. Let's explore how to use the break directive to handle execution failures more effectively. Start by creating a new scenario named Make Intermediate 5 to 3 inches. It's essential to adjust the scenario settings by enabling the option to store incomplete executions. This step ensures that any errors that occur can be addressed later rather than halting your entire process. If this setting is disabled, the break directive won't be functional, and you'll get an error message prompting you to activate the storage of incomplete executions. Much like the ignore option, break focuses on errors at the bundle level. This means if your scenario has multiple bundles to process, the system will continue working through them. However, only the bundle with an error will result in an incomplete execution, making it easier to pinpoint and resolve specific issues. By allowing for this flexibility, Break ensures your workflow isn't entirely disrupted by isolated errors, providing a smoother and more efficient process. To effectively use the Break feature, let's explore how to repeat scenarios automatically. In this exercise, you'll incorporate the repeater module. This tool allows you to run your scenario multiple times, helping simulate real-world processes. Imagine tackling several batches of data. This is where the repeater shines. Begin by adding the repeater module to your scenario from the flow control options in the Tools menu. It's set to repeat 3 times by default, providing a good starting point for most tasks. While you can adjust the number of repetitions, sticking to 3 is often sufficient to see meaningful results. Once you've configured the repeater, make sure to save your settings. This exercise sets the stage for testing scenarios under varied conditions, giving you a robust understanding of how temporary interruptions are managed through automatic retries. In this exercise, you'll learn how to use the HTTP module to simulate automatic retries when accessing a URL. We're going to make this process a bit unpredictable by deliberately causing some requests to fail. Start by adding an HTTP make a request module. For the URL, type in or paste https://httpstat.us/. This is a service that helps simulate different HTTP statuses. We'll use a special function if random 0.5, 503, 200, which decides how the server should respond. Here's how it works. If the random number generated is greater than 0.5 comma, the server returns a 503 status, which signifies a temporary error. Otherwise, it returns a 200 status, indicating success. This randomness helps simulate real-world scenarios where your server may occasionally become unavailable. Select Get under Method to specify how you request data from the server. In the advanced settings, ensure that Evaluate all states as errors is toggled to Yes. This tells the module to treat any response other than a 200 level success as an error. Following this setup will allow you to see the break module retry the request after a failure, enhancing the reliability of your process automation. Now, let's dive into how the break and if functions work together in this scenario. The if function is designed to evaluate three parameters: a condition, a result if the condition is true, and a result if the condition is false. In our example, we're using the function to simulate HTTP responses. The random function generates a number between 0 and 1. This random number acts as our condition. If this number is greater than 0.5 comma, the function returns a 503 error. This simulates a failed HTTP request at the URL we have set up, essentially telling us the server isn't currently available. Conversely, if the random number is below 0.5 comma, the function returns a 200 status code. This indicates a successful request, meaning the server is responding correctly. With this setup, our module will occasionally fail, mimicking real-world scenarios where network stability varies. The key here is the automatic retry mechanism, which is set to execute until it achieves a successful attempt, thanks to the capability of the break function. In essence, the system is prepared to handle transient errors by retrying, ensuring that the process completes successfully without manual intervention. Let's delve into how we can use the break directive to manage retries effectively during execution. Imagine you have a task that might fail. Instead of giving up immediately, we can set it to retry. You have control over how many attempts are made. By default, there will be 3 retries, leading to a total of 4 attempts. The initial attempt plus these retries. You can adjust this number, but it's important to keep within the specified range of 1 to 10,000 attempts. Next, you have the interval between each retry. It's initially set to 1 minute, but you can modify it to 2 or even 3 minutes if you'd like to spread out the attempts. To set this up, right-click the HTTP module and select Add Error Handler, then choose Break. This mechanism ensures that even if something goes wrong initially, the system automatically gives it another shot, up to the number of times you specify. Remember to hit OK once you're done to save these settings. By implementing this, you enhance the reliability of your execution flow, minimizing manual intervention while maximizing efficiency. In this exercise, we're experiencing a scenario where automated retries play a crucial role in managing errors. Imagine you've set up a process and suddenly it encounters 5 errors within 5 minutes. The system doesn't pause. It continues according to your settings. This highlights the importance of staying alert and troubleshooting any issues promptly. You'll receive an email notification alerting you to these errors, which is your cue to investigate further. It's vital to remember that retries are effective only when your scenario is active, so ensure it's scheduled to run at the appropriate times. For this practice, schedule your scenario to execute hourly. This setup provides a clear view of how the retries manage incomplete tasks. And once you're done with this exercise, always remember to deactivate the scenario to prevent unnecessary operation consumption. By understanding and applying these concepts, you maintain control and efficiency in your automated processes, ensuring they operate smoothly even when unexpected errors arise. Now that we're ready to see the scenario in action, it's important to understand the process. Once activated, your scenario will start immediately, allowing you to check the results in real time. Keep in mind we've configured the first execution to repeat retries every minute using the break directive. It's crucial to note that these instant retries won't interfere with your scheduled scenario runs. They only apply to the repeated attempts, keeping your operations seamless. Remember, this setup helps ensure consistent performance even when initial attempts encounter issues. To check your scenario's performance, start by heading to the History tab. This is your go-to place for understanding what happened during an execution. At first glance, you might see a success label, which is promising. However, it's crucial to dig deeper into the details. Inside, you'll likely find warnings and see how many times the break function activated. Break is important because even if you encounter an error, your scenario can still achieve a success status. This happens if the error is associated with a break module that has auto retry enabled. Basically, break steps in to pause and restart the process, giving errors a chance to resolve without interrupting the entire scenario. The break directive doesn't halt everything, though. It manages errors by pausing specific executions, allowing other scheduled processes to continue smoothly. This flexibility ensures your operations aren't disrupted, making it a powerful tool for maintaining efficiency even when hiccups occur. Let's dive into how your scenario is performing. If you happen to be very lucky or unlucky, it's possible you didn't encounter any errors. This means the break feature wouldn't have any entries in the history log for this scenario. To thoroughly test, try switching the scenario off and back on. This action forces it to run afresh, providing another opportunity to catch any errors. Now navigate to the Incomplete Executions tab. Here you'll find an entry for each error your scenario encountered. Notice the retry column is checked, but the attempts count is 0. This setup ensures your scenario is programmed to automatically retry those errors. If you refresh the tab after about a minute, you might notice updates. It's important to be patient, as the resolution might not occur on the first attempt. The system is designed to retry up to 3 times, giving it multiple chances to resolve successfully. Keep experimenting and observing these behaviors as they provide great insights into the robustness and reliability of your scenario configurations. Now that you've had a chance to run your scenario, let's explore what happens if all retry attempts fail. When this occurs, both the retry and resolved columns in your execution log will remain unchecked. This situation can also arise if you opted out of automatic retries when setting up your break directive. To address failed retries, return to the scenario editor. Here you have the option to modify the HTTP module mappings. Specifically, change the URL to https://httpstat.us/503. This URL will trigger the failed retries, providing a clear view of the issue at hand. To dive deeper, click the Detail button. This action opens the scenario editor and shows a snapshot of the specific execution. It's a useful feature allowing you to make targeted changes to resolve the error. Remember, any changes you implement here won't impact your main scenario, just the individual execution you're working on. This hands-on approach empowers you to troubleshoot effectively, ensuring that your scenario operates seamlessly. Now that you've confirmed your scenario is working as expected, it's time to consider the scheduling options you have. You can set your scenario to run once for a quick test or schedule it to run every minute, which is ideal for frequent updates. However, there's an important detail to remember after your testing phase is complete. Make sure to turn your scenario off to prevent unnecessary consumption of operations. Leaving it on could deplete your resources quickly, especially if the scenario is set to repeat regularly, like every minute or hour. This simple step can save you from potential headaches and ensure you manage your operation resources effectively. When deciding whether to retry an operation, it's important to consider the nature of the error. Automatic retries are particularly useful for transient errors, which are temporary issues that often resolve themselves. For example, you might encounter a rate limit error if you've made too many requests in a short period, or you might face issues if an external application experiences temporary outages. Even the most robust services can have occasional downtime due to scheduled maintenance or unexpected overloads. Understanding these scenarios helps you to better manage your processes. Instead of allowing minor disruptions to halt your operations, implementing a strategy to retry can maintain the flow of your activities. However, it's crucial to recognize when an automatic retry might not be the best path. Sometimes you'll need to break the process and address the issue manually, ensuring your systems are as resilient and efficient as possible. Let's explore how the break directive can be a game changer in managing errors. Imagine you're dealing with unpredictable errors. Break offers a simple and effective way to handle them manually. This means you have more control over resolving issues, especially when automatic retries may not be the best solution. Consider scenarios where complex error handling is necessary. You can choose to use break without activating auto retry. This approach can be beneficial in intricate situations where handling errors individually makes more sense. Activating incomplete executions ensures that warnings get logged. It's a proactive way to manage errors efficiently, especially when specific error handling routes aren't available. Another strategic move is applying filters before your error handler. This targets specific errors like rate limits or 503 errors, ensuring that only the relevant issues are retried. For more persistent problems, manual intervention might be required, allowing you to address the root causes directly. In summary, Break empowers you with a straightforward manual approach, providing flexibility and precision in dealing with errors. Let's take a moment to recap the key concepts we've explored. First, enabling incomplete executions is an effective way to convert errors into warnings. This approach allows you to manage issues without immediate disruptions, providing more flexibility in handling problems. The break directive is particularly useful as it automatically retries incomplete executions. This means you can handle situations where errors occur without manually intervening every time. Each bundle or set of data processed is managed individually with break, so if an error arises in one bundle, subsequent ones can still be processed, ensuring continuity. It's important to note that auto retry is only functional in scenarios that are currently active. This is crucial to ensuring that your processes are ready and able to manage retries effectively. Break really excels when dealing with temporary errors. These are issues that may resolve themselves over time or may not consistently occur, allowing Break to handle them smoothly. Lastly, when you manually resolve incomplete executions, any adjustments made won't impact your main scenario. This separation helps maintain the integrity of your main process while allowing for necessary corrections. Reflect on these points to solidify your understanding of how Break enhances error management. You've reached the end of this unit, and that's a milestone worth celebrating. You've made significant progress in understanding how to manage incomplete executions and address issues by retrying them when necessary. If things didn't go as planned, remember you now have the tools to fix them. Feel free to take a well-deserved break, or if you're eager to dive deeper, the next unit will introduce you to the resume directive and advanced error handling techniques using routers and filters, which will elevate your skills even further. Before wrapping up, just double check that you've turned off any scenarios you created during this unit. It's a good practice to keep your workspace tidy and efficient. Once that's done, you're ready to mark this task as complete and move on when you're ready. Keep up the great work.